Hello and welcome, I'm your CodeMonkey. In this lecture we're going to begin creating our character. Let's make a nice character controller so we can move our character in the world. Okay, so first let's begin by creating the character game object. And now usually most beginner tutorials would tell you to just right click, go into 3D object and create something like a capsule. That way you would have the game object with the visual included. However, for a good project structure and good organization, you should always separate the visuals from the logic. For example, here, let's say that I don't want my capsule exactly like this. Let's say that I want my player to be a little bit more skinny. To do that, I would have to modify the scale on this game object. So put it maybe on 0.7, 0.7, so something like this. Basically, by doing that, by modifying the visual, I also modified the scale on the actual player game object. Having a non-uniform scale on a logic game object, that can cause all kind of problems with any kind of logic component. Also, I would prefer to have my character on the floor, but if I put it on y of 0, notice how the character is half underneath the floor. So if I were to use this method, I would have to apply some kind of offset in order to make the visual above the floor. So that would require rearranging all the logic to work with an offset on the y position. So because of those reasons and many more, you should not place both the logic and the visual on the same game object. Instead, you should separate them. So let's get rid of this, and instead, let's create an empty game object. Let's name this the player. Let's put it on 0, 0, 0, okay? And now inside of it, let's create, let's say, a capsule. Now this one, we can easily scale this to get any size and shape you want. So for example, 0.7, 0.7. Then since the visual is a child of the game object, we can also easily offset this. So let's say put it up by about 1 unit. So with this, we can position the visual so that basically the player game object is over here on 0, 0, and the character is above the floor. So we don't have any weird offsets. This will make all of our logic much more simplified. And now on this empty parent game object, we can attach all of the logic components we want. And then in the child visual, we can add or replace whatever visuals we want. So as a general rule, you should always try to do this. Always separate the logic from the visuals in your game object. Okay, so with that we have the player game object. Now let's make our character controller script. And before we do, let's keep things once again organized. So before we do, let's create a brand new folder. So let's right click on the assets, create a brand new folder, call it scripts. And now inside, let's right click and create a new C# script, call it the player, wait for the code to compile, then select the player game object and attach the script. Again, remember logic components go on the parent game object, not the child visual. So the child visual, this one only has visual components, and the player, this is the one that actually has the logic components. So let's open up this script. Okay, so here's our first C# script. Like I said, I'm going to assume you know the absolute basics. Go watch the C# basics video if you haven't seen it yet. So I will assume that you know what is a function, what is a variable, what is start and update, so pretty much the absolute basics. For a character controller, we first need some input from the player. And for that, Unity actually has two methods. You have the legacy input manager and the new input system. Basically, the legacy input manager is super simple and very easy to use, so this one is perfect for quickly prototyping. And the new input system is extremely capable with tons of features, but it's also a bit more complex. So what I do is while I'm doing a simple demo or testing out a new prototype, I just use the legacy input manager, but when making a more complex project, like for example my Steam game, then at a certain point I refactor my code to use the new input system. So here I'm going to teach you both, as well as teaching you how to refactor code, which is an extremely useful skill. So let's first begin by using the simple legacy input manager. We want some basic WASD movement to move our character. And we're going to need to run that logic on every single frame, so let's do it on update. And let's actually get rid of the code that Unity writes by default. Let's start completely from scratch, so let's get rid of this, just close, okay. So here, let's start by writing private void update. And now here, very important, if you're a beginner, make sure that update is written exactly like this. If you write update with lowercase, if you do this, then it won't work. The function will not be called automatically. I'm pointing this out because I have seen a bunch of comments from beginners wondering why their code doesn't work, and it's as simple as this. With lowercase, Unity will not call this automatically. It needs to be exactly perfect. So again, if you're a beginner, make sure you write the code exactly. The code is case sensitive, so this is very important. Also, another note, you saw that the code that Unity wrote by default when we made a new script, it just had void update. It did not have the private keyword. Private is what is called an accessor. You have private, then you have public, and then there are some more advanced ones. Technically, you can omit the accessor, and in most cases it will default to private. However, in writing good clean code, you should be as explicit as possible. There should be no room for misunderstandings. So while technically you could omit the private, you should always include it to make your code easy to read and easy to understand. This one is the first of many clean code rules that I will teach you during this course. Like I said, all of the code that I'm writing here is on the same level of quality that I use in my own professional games. I'm not going to teach you bad practices like so many beginner tutorials do. So always be explicit, always include the accessor. Okay, so we have our update running code on every single frame. Then to test if a key is being pressed, we just go inside input. Then over here we've got two functions. So we have getKey and getKeyDown. Both these functions return a boolean, so that's either true or false. The difference between them is that getKeyDown, this one only returns true for a single frame when the key is pressed, whereas getKey, this one stays true for as long as the key is held down. For example, for an action like jumping, you just want to know when the player presses the button, so for that one you would use getKeyDown. However, in our case, for a character controller, we want to know if the key is being held down. We don't want just one frame, but always. So for movement, let's make sure we go with getKey. That requires a key, so let's write our key code and then choose the key. Let's say we want W. And then let's just put this inside an if, just like this. Okay, so here we have code we want to run while holding down the W key. Let's do a quick test just to verify everything is working perfectly. And for testing, we can use the super useful debug.log. This one lets us print a message in the console. So let's add one log here, just say something like pressing. And then let's also do an else, and if else, let's do a debug.log and just do a dash. Okay, so here is our very basic script. Let's make sure to save it, so Control S. Then back in Unity, over here, make sure you have the script attached to the player game object. And now we can test. And now down here on the console, we can already see dashes, so I'm not pressing any key. Also, like I mentioned in the setup lecture, if you're seeing just one message, then maybe that means you have over here the collapse toggled. If you toggle it, look how it only shows one message, but then over here on the right side, it says the number of messages. Personally, I prefer to always keep it untoggled so I can see every single message. Also, over here on the right, make sure you have info messages visible. If you untoggle this, then you don't see it, so make sure this one, and actually both of them, make sure all of them are enabled. Okay, so we're seeing a whole bunch of dashes. And one more note, if over here the scroll bar stops scrolling, so right now you can see it's stuck up instead of being down there. So if that happens, one easy way to reset that is just click over here on clear, and it goes back into auto scrolling. Okay, so we have the dashes. I am not pressing any key. Now as I press, yep, there you go, there's the message. If you don't see it, make sure the game window is in focus. So select the game view and click right here on the middle to make this one the focused window. Then if you press the W key, you should see the message. And if I let go, yep, there it is, a nice dash. Okay, great, so all the basic logic is working. Back in the code here, now that the logic is working, let's get rid of the else here. And let's add tests for all of the other keys, so let's copy paste this. So we're going to need W, A, S, and D. So let's make all of these. Okay, so we have our inputs. Let's also get rid of the logs. We don't need this. All right, so we have all of our key presses. Now let's construct a vector with our inputs. And since we're just going to have two axes, the WS, that is forward and backwards, and this one is left and right, so just two axes. So because we have just two, let's use a vector2, and let's call it the input vector. Let's construct it, so we'll do a new one and start off at 0, 0, okay. Then over here, the logic is pretty simple. So when we press W, then let's go into the input vector and set the Y to +1. Then when we have an S, we want to go backwards, so put the Y on -1. For the A, we want to go left, so that's an X on the -1. And finally for the D, that is an X on +1. Okay, so with this, we have our correct input vector. Let's do a quick log just to test, so debug.log on the input vector. Okay, so let's test. All right, so we can see in the log 0, 0. Okay, makes sense. Now if I press W, yep, we've got a 1 on the Y. If I press A, we got -1 on the X. Press D, +1. Press S, and -1. Okay, great. So everything works. Except we also need to be careful about one other thing. If I press both W and D, with this, look at that, the vector is 1, 1, which is correct. That's exactly what we did. Except the vector 1, 1 actually has a bigger magnitude than just one vector. If we leave it like this, then the character will move faster when moving diagonally versus when moving in just one direction. For our input vector, we really want it to be normalized, meaning we want it to have the same size regardless of the combination of keys that we're pressing. So back in the code here, after calculating the input vector, let's simply normalize it. So we go into the input vector and we set it equals to input vector.normalized. So this will normalize our input vector. Let's see. Now over here, if I press W, yep, got 1, press S, -1, okay, so all of those work. Now if I press both W and D, yep, there you go, now it says 0.71. When you combine both these and you do the math, these do end up with a magnitude of 1. So with this, our character will move at the same speed on both diagonals and straights. Okay, so we have the input vector all correct. Now let's actually apply some movement. For that, there are many ways of making a character controller. For example, you can decide to use physics or not. Over here, I want to keep the game simple, so let's not use physics. Instead, let's just move the player transform directly. Over here, we have our input vector. Okay, great. Now we want to apply this to our character position. So first, we access the transform. This one refers to the transform where this script is attached to. This script was attached to the player, so this is going to refer to the player transform. Then we want to modify the position, so let's access the position. And now for moving, we don't want to just assign it. If we do something like this, the player would never leave the center of the world. It would always be near 0, 0. So instead, we don't want to just assign it, but instead we want to add onto it. Now, if you're a complete beginner and you don't know this syntax, then this one is exactly the same as this. So transform.position equals transform.position plus input vector. So both these two lines are doing the exact same thing. Personally, I prefer to use the shorthand. I find that equally readable and more compact. Okay, so we have this, and we add our input vector to the transform position, except we can also see a really nice error. Basically, it's telling us that we are mixing two types. Our input is a vector2, where we only have an x and a y, but transform.position is a vector3, meaning it has an x, y, and z. One simple solution is to cast our input vector onto a vector3. So we just convert this from one type into the other one. And yep, we don't have the error, so let's test. And now if I press W, and yep, the character does move. Let's ignore the massive speed for now. So it does move, it does seem slightly correct. Except you can obviously notice that it's not correct. We are moving on the x-axis, so left and right, that is correct, but then we are moving up and down instead of forwards and back. Basically, we converted the vector2 directly into a vector3, so we are moving on the x and y axes. But in our 3D game, we really don't want the characters to fly, so instead we want to move on the xz axes. So back in code here, instead of directly casting this down into a vector3, let's construct a move dir vector. So let's do a vector3. Let's call it our move dir for our move direction. And over here, we construct a new vector3. And basically, we're just going to assign the input y to the z on here. So first of all, for the x, that one is correct. So input vector.x. Then for the y, let's leave this one on 0. And finally, let's use the input vector.y as a z on the move direction. Also, now at this point, you might be questioning, if we're using a vector3 here, why don't we also use a vector3 up here and then just assign the z directly? That's certainly a possibility, and for making a super quick prototype, I might even do that myself. But the proper answer to that is once again all about writing good clean code. The input logically only has two axes. There's no z axis on your keyboard, so logically it makes no sense for the input to have three axes. And beyond that, you should keep the logic separate, so you should first get the input and then actually move the object. We're going to see the benefit of that separation when we refactor this code to work with the new input system. Doing that will in turn make enabling gamepad joystick support super easy because we have the input vector separated from the actual movement. So all of that to say, let's do things properly. Let's keep the input vector separate from the movement vector. So we just translate the xy onto xz, and then we just apply this into our transform position. Okay, so let's test. So now if I press D, go right, go left, and press W and S, and there you go. Okay, great. So it is indeed moving left, right, forward, and back. Okay, great. So it is working, but as you can see, it's moving insanely fast. You might think the issue here is just applying some sort of movement speed multiplier, except there's actually one sneaky issue here. Here on the game view, on the top right corner, we've got a stats button, and over here we can see a whole bunch of things. Specifically, we can look at the frame rate. We can see that it's running at 144 frames per second. Over here on the left side, on this button, I have VSync enabled. This will cap the frame rate to the monitor's refresh rate, so that is why I'm seeing 144 Hz. I can over here disable VSync, and yep, look at that, goes all the way up to 700. Basically now the game is running as fast as my computer can run it. And if I press the movement keys, and look at that, now it's moving even faster. Now I've completely lost track of where my player is. This is not what we want. We don't want the player to move at different speeds depending on the frame rate. We want it to always move at the same speed regardless of frame rate. So when you do any kind of movement logic on an update, you always need to make sure to multiply by time.delta-time. What this variable contains is the number of seconds elapsed since the last frame. For example, let's add log to this. We no longer need the input vector, so let's log just the time.delta-time. Okay, so we can see there, that is basically telling us how many seconds it is taking to render a single frame. Once again, note how I have VSync enabled, so I'm running at 144 frames per second. And now if I disable it, let's see what happens to that number. So if I disable, and yep, look at that, that number is now much smaller and the game is now running much faster. So by incorporating this value into our calculation, we are going to be taking into account the frame rate, thus making sure that the movement is always frame rate independent. Right now with this frame rate, if I move, you can see I'm moving at this speed, and now if I enable VSync, change the frame rate, and I move and I'm still moving at the exact same speed. Okay, that's great. Except obviously it's not exactly great, it's moving way too slow, so let's also incorporate a movement speed. Now for this, once again, most beginner tutorials would teach you to go all the way up here and define a public float move speed. Maybe default it to some value like 7f, something like that. Then you have this field, and then down here you simply use it in the calculation. So movement here, multiplied by move speed and by time.time. So this is what most tutorials would teach you. By making it public up here, what you're doing is you're enabling access from the editor. So if you go over here in the editor, over there on the player, we can see the move speed variable. We can see this exposed and we can modify it. This makes it really easy for testing and for iterating upon the value even while the game is running. So the game is playing, I can move and I have this move speed. Now I can modify this, and yep, now I got a different move speed, so I can use this to quickly iterate and find the perfect value. So it's great to have this variable exposed in the editor. And this feature is indeed the reason why most beginner tutorials would teach you to make it public. It's so you can see it in the editor. That is indeed a very valuable thing. Being able to easily iterate upon important values is always very useful. However, when you make something public, when you do that, you don't just expose the field to the editor, you are exposing it to every other class in your entire codebase. So some other class could access this field and set the player's movement speed to something like 0, and you would have no idea that was happening because the issue would not be on this code right here. I have an entire video on this subject, why you should not make everything public. This is an extremely important topic to know about. This one tiny change will massively improve the quality of your code. Definitely go ahead and watch that video to learn why it's such a bad thing and make sure you don't do it. So to avoid all kinds of problems, you should never make fields public. So very quickly, the obvious alternative is make it private. Making it private means that only this class, only the code in here, only this can modify this field. So you know for certain that no other class can ever modify this. However, making it private also means the editor cannot modify this field. So we've lost our very useful iteration approach. So what we can do to expose it just to the editor is to keep it private, and then we add the attribute serialize field. This way this field is still private, meaning that it can only be modified by the code inside the player class. But with this attribute, over here in the editor, yep, we do have an editable field. So only the code in that class in the editor can modify it. Nothing else can touch it, nothing else can read or write, which is exactly what we want. One of the main rules in writing good clean code is minimizing complexity, and one of the easier ways to minimize complexity is simply to minimize access. By making this field private, we are minimizing complexity because it doesn't matter how complex our game is. Maybe our code base is 1,000 classes long, it doesn't really matter because only this class can ever touch this field. So if we have a bug related to movement speed, we know for certain it has to be inside this code and nothing else. So we minimize the things we need to keep in our head, which is always a very good thing. Okay, so with all that said, we have our movement speed, and down here we are incorporating it into our calculation. Just with this, we have our character working with a variable movement speed, and by using delta time, we have our movement correctly being frame rate independent. So here's our character, and using the keys, I can walk around, and yep, the character moves in any direction. So we have movement fully working while using the legacy input manager. Like I said, we're going to learn how to refactor our code to use the new input system. Learning how to refactor is an extremely important skill to improve your own programming skills. It is something that you should always do when necessary. It will massively help you improve the quality of your code. So we're going to do that, but before we get to that, let's actually do something a bit more fun and add some proper visuals and animations to our player in the next lecture.